This is what we are going to build over. We have an HTTP trigger functional, which is going to bring a message to the event hub. We will have another functional, which is going to pick up the event from this event hub subscription, do some processing, and save the result to a new blob object. First, let's go ahead and create an event hub. I have it bookmarked under my favorites, so I'm going to click on it. As you can see, I already have an event hub created. Let's go ahead and get it in the resource group I created for this course. And here I'm specifying
People create great applications in the Google Cloud. Popular tools for development, deployment, and monitoring just work in GCP. You also have options for tools that are tightly integrated with GCP. Setting up your environment in GCP can entail many steps. setting up compute, network, and storage resources, and keeping track of their configurations. You can do it all by hand if you want to, taking an imperative. Approach. In other words, you figure out the commands you need to set up your environment the way you want. Change your environment. You can't run an application stably without monitoring. Monitoring lets you figure out whether the changes you made were good or bad. with information rather than with panic when one of your end users complains that your application is down. Stackdriver is GCP's tool for monitoring, logging, and diagnostics. Stackdriver gives you access to many different kinds of signals from your infrastructure platforms, virtual machines, containers, middleware, and application tier, logs, metrics, and traces. It gives you insight into your application's health, performance, and availability. So if issues occur, you can fix them faster. Here are the core components of Stackdriver: monitoring, logging, trace, error reporting, and debugging. Stackdriver monitoring checks the endpoints of web applications and other internet accessible services running on your cloud environment. You can configure uptime checks associated with URLs, groups, or resources such as instances and load balancers. You can set up alerts on interesting criteria, like when health check results or uptimes fall into levels that need action. You can use monitoring with a lot of popular notification tools, and you can create dashboards to help you visualize the state of your application. Stackdriver logging lets you view logs from your applications and filter and search on them. Logging also lets you define metrics based on log contents that are incorporated into dashboards and alerts. You can also export logs to BigQuery, Cloud Storage, and Cloud PubSub. Stackdriver error reporting tracks and groups the errors in your cloud applications, and it notifies you when new errors are detected. With Stackdriver Trace, you can sample the latency of App Engine applications and report per URL statistics. How about debugging? A painful way to debug an existing application is to go back into it and add lots of logging statements. Stackdriver Debugger offers a different way. It connects your application's production data to your source code, so you can inspect the state of your application at any code location in production. That means you can view the application state without adding logging statements. Stackdriver Debugger works best when your application's source code is available, such as in cloud source repositories, although it can be in other repositories too. Let's look at the file again and see our results. Our GCP zone has been substituted into the template, as has our GCP project ID. Now we're ready to build a deployment from this template. The template will create a new deployment in Compute Engine. It'll be called MyFirstDepl, and it'll use the template mydeploy.yaml. It's done. We can confirm its status using the gcloud command. There's our deployment, MyFirstDepl. Now let's look at the resulting virtual machine. We'll go to the Compute Engine VM Instances page. There's our virtual machine, my-VM. We click on its name to open its details and scroll down, and there's its startup script, apt-get update. Now let's make a change to our template. I'm going to add a command to the startup script. This new command installs the Nginx Lite web server. Now we'll update our deployment. Now that the update is complete, let's go back to our virtual machine instance detail page. And now look again at the startup script. The startup script has been updated. Now let's put some CPU load on the VM we created and monitor it using Stackdriver. First, we'll log into the virtual machine by connecting to it using SSH. This Linux command creates an artificial CPU load on the virtual machine. In essence, it forces the CPU to continuously attempt to compress random data. Now let's return to the GCP console and set up Stackdriver monitoring. In the Products and Services menu, we scroll down to Stackdriver Monitoring. We confirm that we want to create an account. And we'll confirm that we wish to monitor our GCP project. For this particular activity, there's no need to install Stackdriver monitoring, so we just click
Wow.
Google believes that in the future, every company will be a data company because making the fastest and best use of data is a critical source of competitive advantage. Google Cloud provides a way for everybody to take advantage of Google's investments in infrastructure and data processing innovation. Google Cloud has automated out the complexity of building and maintaining data and analytics systems. In this module, I'll tell you about Google's technologies for getting the most out of data fastest, whether it's real-time analytics or machine learning. These tools are intended to be simple and practical for you to embed in your applications so that you can put data into the hands of your domain experts and get insights faster. Google Cloud Big Data Solutions are designed to help you transform your business and user experiences with meaningful data insights. We like to call it an integrated serverless platform. What does that mean? Serverless means you don't have to worry about provisioning compute instances to run your jobs. The services are fully managed, and you pay only for the resources you consume. The platform is integrated so that GCP data services work together to help you create custom solutions. Apache Hadoop is an open source framework for big data. It is based on the MapReduce programming model, which Google invented and published. The MapReduce model is, at its simplest, means that one function, traditionally called the map function, runs in parallel with a massive data set to produce intermediate results. And another function, traditionally called the reduce function, builds a final result set based on all those intermediate results. The term Hadoop is often used informally to encompass Apache Hadoop itself and related projects such as Apache Spark, Apache Pig, and Apache Hive. Cloud Dataproc is a fast, easy, managed way to run Hadoop, Spark, Hive, and Pig on Google Cloud Platform. All you have to do is request a Hadoop cluster. It will be built for you in 90 seconds or less on top of compute engine virtual machines whose number and type you control. If you need more or less processing power while your cluster is running, you can scale it up or down. You can use the default configuration for the Hadoop software in your cluster, or you can customize it. And you can monitor your cluster using Stackdriver. Running on-premises Hadoop jobs requires a capital hardware investment. Running these jobs in Cloud Dataproc allows you to only pay for hardware resources used during the life of the cluster you create. Although the rate for pricing is based on the hour, Cloud Dataproc is billed by the second. All Cloud Dataproc clusters are billed in 1 second clock time increments, subject to a 1 minute minimum billing. So, when you're done with your cluster, you can delete it and billing stops. This is much more agile use of resources than on-premise hardware assets. You can also save money by telling Cloud Dataproc to use preemptible compute engine instances for your batch processing. You have to make sure that your jobs can be restarted cleanly if they're terminated, and you get a significant break in the cost of the instances. At the time this video was made, preemptible instances were around 80% cheaper. Be aware that the cost of the compute engine instances isn't the only component of the cost of a Dataproc cluster, but it's a significant one. Once your data is in a cluster, you can use Spark and Spark SQL to do data mining. And you can use MLlib, which is Apache Spark's machine learning libraries, to discover patterns through machine learning. Cloud data proc is great when you have a data set of known size or when you want to manage your cluster size yourself. But what if your data shows up in real time or it's of unpredictable size or rate? That's where Cloud Data Flow is particularly a good choice. It's both a unified programming model and a managed service, and it lets you develop and execute a big range of data processing patterns: extract, transform, and load, batch computation, and continuous computation. You use data flow to build data pipelines, and the same pipelines work for both batch and streaming data. There's no need to spin up a cluster or to size instances. Cloud Data Flow fully automates the management of whatever processing resources are required. Cloud Data Flow frees you from operational tasks